I'll be going through the day one Linux training today.
All right,
so in terms of Linux, so the term Linux is a bit of a more general name for a sort of family of Unix-like operating systems. So, and what Linux has is different distributions, so different types of it, and these are built by either the community or other software vendors that deploy it. So an example of a Linux distribution could be, you might have heard of Ubuntu, Debian, Fedora, and these are what's known as open source. And get it? So, okay, so for those that haven't seen terminal before, it will look something like this. So it means I can type commands in to the terminal, but actually at the moment this is talking locally to my Mac. Okay, a brief introduction to what Linux is. Why do we use it? The low cost part. We've already gone into the sort of open source side of it, so people can start up, basically run a system and not have to pay for it. Whereas if you wanted to purchase a Windows, you have to have what's known as a Microsoft license. So a lot of people will utilize it to sort of save money. The open source nature of it as well. It means that people can also develop stuff a lot quicker. Actually, I got confused when I first started in sort of getting exposure to Git and GitHub, because they sound very similar, but actually there is quite a big difference. They are separate. Okay, so first off, I think we do need to actually explain what Git is. So Git itself is actually a client. So it's a bit of software that basically allows you to do what's known as subversion. Okay, so you do that. All right. So I think we've sort of already covered some of this already, but yeah, why we use GitHub. So the great thing within GitHub, and why a lot of people use it, startups use it, etc., is a lot of the services, the basic services, you can get for free. Okay, so and those that have got a GitHub account will have already experienced that. So yeah, already sort of covered some of this slide. This is just basically going through the fact that why we have GitHub. It's basically to help collaborating on a project. It makes life a lot easier. We talked about Git, so Git being the sort of application that runs locally. Now, when this was first designed, okay, this was purely designed as a command line tool. Okay, so not very intuitive in that sense. That's why a lot of people get sort of put off with Git and things like that, because actually to start learning it is not the easiest. Okay, so again, it does take a lot of effort to sort of get au fait with it, and more helpful. So so you can't really see too much from this one, but I'm not sure. Just on this image here in the background, you can actually see the sort of pictorial representation. So as you're modifying files, etc., you can see how they've been modified over time. And there's a thing called branching, which you will come on later, but I won't go too deep into that, but you can see here it's got a nice graphical interface, etc. So there's good and bad reasons for using the GUI clients. It's a lot easier to get started for beginners. It sort of helps you out a little bit more, that sort of visual aid. So yeah, a lot more friendlier, I would say. Some people just prefer it, if I would say no.
Right, so Git day two. Let's proceed. I guess, I assume when you did Git 1 that you were encouraged to create an account and start using it. So hopefully you've done that. If not, I would definitely encourage you to. The best way to learn something is to use it. I mean, I also would say that actually, using it in the real world is an even better way. I was aware of Git and started to use it, but it's only really when you're put in a situation, you know, perhaps with a customer's Git environment. Let's say you're not yet at the point where you're using Git in a customer environment. Create your own environment and play around with this, because it's much better to do that and try to get up to speed in your own environment, in your own safe environment, before dealing with customers. I suppose recovering what this is saying. So commit, obviously, is the most important feature, right? Of the whole purpose of Git is to be able to collaborate with other people that are obviously not sat next to you. They could be anywhere in the country or the world. Let's say it's not collaboration. Let's say it's your own project. You're the only one working on it. It's a really good. And if it's code, obviously it's got to be code. But if you're working on a project, and you want somewhere to store it securely and make changes to it and see exactly what you've changed, and also have a history of everything that has been changed. That's ultimately what Git is all about.
Good morning, guys. So today we're gonna do Git 3. So let's start. So the first thing we have today is Git branching. So I'm sure you guys will be familiar with the basis of how Git works. It's all about branches and basically developing features within those branches. And this way, you could basically work simultaneously on different things within a project. So looking at Git add, Git commit, Git push, which is pretty much standard when it comes to using Git. Then you have Git fetch and Git merge, which you'd want to use in particular situations, which we get into. Then you have Git pull, which is another common one, which is very straightforward. And then you have Git clone and then a Git checkout. So context is important. So on large projects, we often work in multiple contexts. All right, so you're working on 2 different color scheme variations for your website at the same time, unsure of which you like the best, right? So, once again, like I said before, you could work on different features all simultaneously. So yeah, branches, you guys would be familiar with branches, right? Think of branches as an alternative timeline for projects. They enable us to create separate contexts where we can try new things or even work on multiple ideas in parallel, like we just discussed. If we make changes on one branch, they do not impact the other branches unless we merge the changes, right? So that's important to know. So so I was recommended that you create you initialize a repository, right? So you use Git init, and it will just initialize a local repository in that working directory, right? And when you do Git add, you then, as you mentioned earlier, you start tracking those changes, right? And you move it to the staging area. And then when you do Git commit, you then move those changes to the local repository, or those new files to the local repository, right? And then once it's in the local repo on your machine, right, in that directory, you then do Git push to push it to your remote repo on GitHub. Right. Now we're gonna look at head, right? So we'll often come across the term head and Git. And I remember when I just started with Git, every time I see head, I used to panic because I used to be like, oh my gosh, like I did something wrong, like they're talking about head, right? But there's nothing too scary, right? So head is simply a pointer that refers to the current location in your repository. It points to a particular branch reference. So far, head always points to the latest commit you've made on the master branch, but soon we'll see that we can move around and head will change, right? So you can see master branch, one of your colleagues Ben is working on this branch. Yoga has worked on this branch and reached the backend to main, or master, I should say. And then you have your head branch where you're currently at.
Guys,
so
it's day 4 for Git. We're gonna learn a bit about Git and do some practices. It's mostly gonna be practice, I believe. So yeah, let's get started. I believe git pull is another command we can use to receive changes from a remote repository, like fetch, pull. Unlike fetch and pull, it actually updates our head branch with whatever changes are received from the remote. So basically, normally when you do git pull, right, it takes the content from the remote and replaces the content that is on our local machine as well as our directory. And what fetch used to do, it used to pull the content from the remote, the code base and stuff, but it used to take it to a local, but it didn't use to replace our workspace, right? If we go to the next slide, you can see it is visually shown that, let's say that's your remote repository, right? And that's your local repository. So when you do fetch, it comes to the local repository, right? But when you do pull, it comes to the local repository as well. Directly it comes to the local repository, then directly to your workspace, for example, right? So what it does is normally you can, there are merge conflicts as I've told you. So what happens is, let me create a git here. So what I'm gonna do, I'm going to create a git. Yeah. So I'm in a directory already. So let's initiate a local git. So we can do that using git init.
Okay. Hello everyone. So my name is Kaustubh Prajapati, and I'm your DevOps trainer. So today we are going to go to Terraform. So I hope you guys are familiar with cloud concepts, a little bit of EC2 instances, and DevOps concept. So Terraform is the tool that we use for infrastructure as a code. So generally when we go to cloud and we create something in the cloud, maybe EC2 machine or S3 or something else, then we go to the cloud console, we click some buttons, we go to EC2 machines, and then we click some configuration for the EC2 machine. That could be the AMI, that could be the VPC, that could be something else, right? And then that's how we create an EC2 machine. So if you, for this particular class, we're gonna need some prerequisites. The first thing is we need a laptop, a machine with either of these operating systems. Currently, I'm using Linux. You guys might be using Mac OS or Windows. So everything is pretty much similar, just the installation process can be a little bit different. We'll go through this in deep a little bit later, but for now, these are the things that we're gonna type it out in our code so that we make it happen, okay? Is this good enough? Right?
Yeah, it's
okay. Yeah, thanks. So as we are discussing about the infrastructure as a code, so there are some benefits of it. Why to use it, right? So one example that I give you right now was let's say we have to create thousands of different servers. Then for a single server, we might take like 10 to 20 minutes. So if we multiply by 1,000, then you can see the time it takes, the amount of work manpower it takes, right? Now there are different type of categories for as an infrastructure as a code. So the one that we are currently focusing is the Terraform. So there is something called CloudFormation that is AWS specific, and there is something called Ansible and Safe. So these are not really an infrastructure orchestration, but it is more like a configuration. So let's say if we have to create an EC2 machine, then we use this infrastructure orchestration over here. And if you want to configure the EC2 machine, let's say what to install, like maybe we want to install Node.js, maybe we want to install Python, maybe we want to install web server, then this setup will be done by Ansible or Safe, right? Okay, Terraform installation. I will show this in a demonstration as well, but for the slide's sake, let's just go through the slide and see how the installation is done. So the Terraform installation is quite simple. So it's just like one single command or one file download, and then you can install it. So it's similar to that. So it have one single binary file. You can download it and you can install it, right? So for Mac and Linux, something like that. Hello everyone. If I just so today is day 2 for our Terraform. Last time we declare certain contents statically, right? So whenever we create a resource, for example, this particular code, you can just increase the size of this. Yeah. So this particular code, it is for security group, right? So resource is security group, and it has certain CIDR IPv4 content over here. So there are different ways to set up a variable. So we got variables, the tf file over here, and we also got something called the file that ends with tf parse. So there are two different type of variable files that we are using in Terraform. So what are the benefits of using the variable? Like I said, update important values in one certain place instead of searching and replacing through them entire code. So you don't have to search through entire code base. There could be hundreds and thousands of places that the variable being used, and then you can just change it in one position. And and the second benefit is like you don't need to touch the core Terraform configuration file. So if you are using a static value, so you can see this particular code is actually a Terraform configuration, right? So if you want to change the value somewhere, then you need to rewrite this code, right? You need to update this or you need to change this. So that can actually impact your code structure as well. Let's say a lot of different people are working on it and someone changes over here, then the second person might not know where the actual changes has been made. It will be a little bit difficult for that person to understand what the changes have been made. But if you are using the variable and you are changing the variable name or variable value, then it will just be changed in this particular variable file, not in the code. The code will have the same variable name, but if you want to change the value, then you will be changing this particular value. So yeah, that's the second thing. And with this, we can avoid human mistake while editing or changing the values, right? Now, how do we manage the variables? Managing variables in a production environment is one of the very important aspects to keep the code clean and reusable. So by default, HashiCorp recommends us to create something with a file that ends with tf parse to define all the variables value in the project. So we will see that in a little bit. Fine. So there are two files that are linked with variables. First one is variables, the tf file, where we actually define or declare all the variables. Like for this particular project, these are the variables that are going to be used in this project. So we define VPN IP, a port, or maybe name, or maybe tags or something else, right? There could be a lot of different stuff over here. And another file that is Terraform tf parse, where we actually put the value of that particular variable. Okay.
Please.
I missed one thing, which is AP. Let's say you are the prefix is actually the prefix for the workspace. For example, let's say you are specifying it as London, right? Now the actual key for this whole thing will be actually London / the workspace name / this key, terraform.state. So whatever you name the workspace, it will go to that. So if it's dev, it will be dev. If it's right now, if it's prod, it will be prod. Internally, one thing from my industry experience, it is not recommended to use workspace. It is not very healthy to do so. So basically, when you use workspace, it can be very messy when you have a lot of resources and the system is really complicated. So when you, let's say you have got 10 instances inside production, but in dev environment you just want 2 to reduce the cost. So yeah, and now we are in team collaboration, right, where obviously when you work with a team, you won't be working alone. You won't be writing code mostly. You will have other developers or other DevOps engineers who will write code and update the repository or the resources using Terraform, right? So that's where you will have to think things differently. So when you working alone, you can just push the code, or you can just run the Terraform command directly from your command line, right? So that's where you use git ignore to exclude few things. This is very important because your directory, when you have locally run things, Terraform init, Terraform plan, you can have very sensitive information or a lot of files that are not necessary to reside inside the repository. So you want to include those files inside git ignore, right? Where I hope you understand what is git ignore, what is the purpose of the file. In git ignore, you can specify things like .terraform, tf vars, which has sometimes has username, password, sensitive information like this. You can have tf state, you can have crash log, stuff like that.
Within Terraform, you've got different data types as well. So we won't go through all of them, but hopefully most of these are clear. So the different data types you've got, like string, so basically text. Within it, numbers, you've got Boolean, so you can set things to be either true or false. So if true, do X, if false, do Y. Lists, so you can have like a sequence of values. So it might be a list of, like, within AWS, something to do with your availability zones and things like that, and you need to pull that out and put it into a list. That's cool. Just some helpful stuff as well. So when you're sort of debugging, you can set different log levels as well. So if something isn't working and you're not getting too much help with it, you can certainly set it to sort of debug. You probably don't want to leave it on that, because otherwise your logging is going to get quite large. But yeah, you can certainly set these to help you identify any issues. Cool. Yeah. So so you can take your manually created resources, import them in, and then you can then start to manage them going forward through that. All right, and then local values. So local values are used when you want to sort of set local variables and things like that, and it avoids, if you want to sort of keep putting the same section under it, an example being tags and things like that. So you would want this to go across, like
I'm Kaustup Prajapati, and today we'll be having a session on Docker. So Docker is an important aspect of DevOps engineering. Okay, so before diving into Docker, let us understand why we need a Docker, why it is used for, why modern DevOps use cases require Docker more than ever. So if you guys are familiar, if you guys are working in IT or any other software development stuff, or even if you are not non-technical, you guys might have heard this terminal. It works on my machine, right? So people, when they write codes, usually what they say is like, it working on my machine, But when I try to deploy it in other servers, maybe actual server or the testing server, and it start to cause some error or issue. Now, why is that? Right? So this might happen in a regular basis. This is a very common issue when you work on IT or when you are a software developer. Whenever a developer works on his code and then he try to test it on certain servers, maybe on a local server or maybe in a remote server or in a cloud, and the same code that works in his laptop doesn't work again. And later on he goes back to his laptop and he sees that the code or the work, it works on his machine, but it doesn't work on a server. So this is the quite serious problem when you work in a real life. So to solve this, the Docker came in handy. Our core content. Just give me a second. Yeah. So yeah, we will go through the simple introduction in this slide as well. But before you understand Docker, what Docker is, you need to have some prerequisites. Like you need to have a laptop, a system with any of these operating systems. It's better you have a little bit of understanding of AWS, such as S3 or EC2 machines specifically, and you have conducted some lab as well, so that you are familiar with how the Linux system works, how the command line works. We also have one demonstration for AWS account. So we will be using AWS and how to set up a Docker in it. So you need to have an AWS account to test it out. And then GitHub account, if you are trying to pull the code from any other workers who have done Docker, who have created Docker files, and you're trying to use them, then GitHub is needed. And for your code or terminal, manipulation, you need VS Code and Git Bash. Okay, so today's training is about Jenkins. So what is Jenkins? It is one of the most popular automation tool used worldwide for continuous integration and continuous delivery. Now, why Jenkins? What is the use case of it? Now, before diving into automation CI/CD, right? So let's say this is the CI/CD section. So before this, we had a lot of different issues, okay? The issues are, number one, slow release. Now, why Jenkins? The first thing is Jenkins is widely used, most popular. People have a lot of different plugins, right? So the first thing is it supports automated building, automated testing, automated CI/CD, and automated deployment. So like if everything that we talk about here, so we can do automate on all of this. So today's session is going to be about Kubernetes. Last time we did talk about Docker, right? And we did dive a little bit deep inside Docker Swarm, how the Docker Swarm actually works, why it is used for. So today Kubernetes is an alternative for Docker Swarm. Okay. So previously, when when the internet was there, when people started hosting their web server or any sort of services that you want to, then generally what they got is they got an hardware. So they buy some CPUs, memories, RAMs, Kubernetes and Docker Swarm. Yeah, again. So here Kubernetes is more complex architecture. It has got advanced features. It is expensive, so it has extensive ecosystem. So it means, like, let's say more people are working on Kubernetes and less that is compared to Docker Swarm. So if you want help with community, if you want other people's code to use extensively, so yeah, then you can use, then Kubernetes is better for that. Okay, so what is Kubernetes? We will just go through the slides a little bit, and we will also do some Kubernetes demonstration. And yeah, probably that would be the thing for today's class. It is an open source orchestration tool, so you need to know, like, this is an open source tool. Like, it is not proprietary to any company, so anyone can use this without any cost. So it is free to use. So today we'll be continuing with the Kubernetes day 2. So day 2, we're gonna start with namespace. So I think we did talk about the namespace. It's about a logical placement, or it's more about a logical containers. I didn't get a word over here. Okay, I would say division. Okay, so we got a cluster and we got multiple pods inside the cluster. but we want to divide them into some logical section so that we can query it, we can manipulate it on the basis of needs. So yeah, with a namespace we can do that. Okay.